Hello students. Today we will talk about some very important and basic topics of chemistry. So first topic is symbols and electronic configuration of the elements having the atomic number 1 to 20. Second we will talk about valence electrons, then valency, and finally we will talk about the molecular formula of the compound. Okay, so these are the elements having atomic number 1 to 20. I hope you all know these topics very frequently, but it is also done here to you. Okay, so we have these 1 2 3 4 5 6 7 8. These are called groups. Okay, and when we move left to right, it is called, this horizontal row is called periods. This, it means when we go left to right or right to left, so this whole horizontal row is known as period. And if we move from top to bottom, these are called groups. Okay, okay. Then after, the very important topic for you, it is how can you write the symbol of element, what is the process. Okay, and correct method you can say. So you can see it is a general element that we are denoting by the x. Okay, and left side in bottom we put z, and in the top side we had put a. So what is these z and a indicates? Take a look here. So Z, that is called atomic number, and it is equal to number of protons, that is P, I written here. Okay. Next one we have A, that is mass number. You can see there is a capital A also written on the top side or on the left side here. So it is called mass number basically, and which is equal to number of proton plus neutron. It means if you want to know how many number of neutrons are present there in an element, you can say, so you only have to do, that is A minus Z, means it is proton plus neutron, initially first by A, and then Z. Z is number of proton, you all know. So by this means P will cancel out and you will get the number of neutrons in a element. Okay students. Okay. Now let's move to the next topic that we are talking about. It is electronic configuration. It is very important and very easy topic you can say. But you have to know some basic concept. Okay. So it is electronic configuration. We have a simple formula here that you will use, K, L, M, N, and these are the maximum number of electrons that can enter in these principal shells. Remember that this formula we will use only for the first 20 elements. Okay, for after the elements 20 atomic number basically, so we have other SPDF formula, so I will tell you in the next video possibly. Okay, but initially we are talking about very basic concept because of for 7th 8th 9th 10th you can say. Okay, so it is the method by which you can fill the electrons. Now, what is the meaning of electronic configuration? If we say, so simply you can say filling of electrons in different orbits in an atom. Okay, okay, beta. So, like if you know, the atomic number of the elements, then you can write, because okay, let me show you one special formula also. You can say if we have neutral atom, What is the meaning of neutral atom? There is no charge present on the atom. Okay. So in that condition you can say number of proton will be is equal to number of electron, and this will be is equal to also you can say atomic number, because we all know atomic number is equal to number of proton beta. Okay, so now if we know the number of proton, so it means we also know the number of electrons there, and electronic configuration is nothing but only the distribution of electron in the different orbits in an atom. Okay, so now if like this carbon you know, okay, and its atomic number is 6. So if we write the electronic configuration of carbon, so what it will be, like in very first K shell, maximum number of electrons that can enter it is 2. So we have filled 2 electrons in the first shell. Now the remaining electrons we have, it is 4, because total electron was 6 and 2 electrons filled in K shell. So only 4 electrons are present. So which will enter in L shell, because it can accommodate 8 electrons, but we have only 4 electrons. So this will be the you can say electronic configuration of carbon. Now if we have neon, okay, it is noble gas, you all know. So its atomic number is 10, we all know. So initially 2 electrons will enter there and 8 electrons are left, so all electrons will enter in the next L shell. So it will be the electronic configuration of neon. कट करूंगा मैं उसको, कट करूंगा उसको. Okay, now we have sodium, that you all know. 11 is the atomic number of sodium. So now initially 2 electrons will enter in K shell, you know. Now 9 electrons are left, but in next shell max to max 8 electrons can fill, you all know. So 1 electron will left there, so it will enter in the next shell, that is called M. Okay, so 281 is the electronic configuration of the sodium. Okay, like this you can write the configuration of any element if you know the atomic number. Like 16, it is sulfur, you all. So its electronic configuration will be initially 2 electrons will enter, then 14 remaining, then 8 will enter in the next L shell, then 6 electron remains there, so it will enter in the next shell which can accommodate 6 electrons easily. So it is the electronic configuration of sulfur. So only by knowing the atomic number and if it is a neutral atom, so you can write this kind of configuration. If we say the electronic configuration of ions, so for ions simply you have to know, if it is positive charge it means the same number of electrons lost by the atom takes place, and if it is negative charge it means the negative charge present, the same electrons are accepted by the element. Simply you can say if we have O, it has 8 atomic number, you all know. So if it gain 2 electrons, so it will convert O to negative, and this 2 negative indicating that 2 electrons has been gained by this oxygen atom. So its number of proton remains same 8, but electron will be now 10. So if you write the electronic configuration of this ion, So it will be 2 8 because now total 8 electrons are present there. Okay, and okay, now we are talking about valence electron. Valence electron basically you can say nothing but the total electrons present in the very last shell of an atom. Like for carbon 2 4 is the electronic configuration, so 4 electrons are present in the valence shell, means the outermost shell is called valence shell. So its valence electrons are 4. If we say sodium, so you all know now 281 is the electronic configuration for sodium because of, so the last shell containing only one electron. Okay, so its you can say valence electron is 1. If we say oxygen, so it is 2 6 configuration because of, so here the valence electrons will be 6 because 6 electrons are present in the outermost shell. Okay, beta. Now the next topic we have, it is valency. If we say valency, you can say the number of electrons gain, loss, or share by an atom to complete octet in its valence shell. इट मीन्स बेटा कि अपने वैलेंस शेल में इलेक्ट्रॉन 8 कंप्लीट करने के लिए कोई एलिमेंट जितने इलेक्ट्रॉन गेन, लॉस या शेयर करेगा, इट इज नोन एज इट्स वैलेंसी. ओके, सो how can we identify which one will lose and how many electrons will lose or gain? So simply you can say if an element has 1, 2, or 3 electrons in its valence shell. It means 1, 2 or 3 electrons are valence electron in a shell. Okay, so it will lose these electrons and will form positive charged ion, which is called cation, and it is the property of metals generally we say. Okay, and if it is 5, 6 or 7 electrons in the valence shell, so if the element have 5 electrons in its valence shell, so definitely to complete octet means 8 electrons in the valence shell, so it will gain 3 electrons, then it will be 5 plus 3 and it will be 8. So 3 electrons that are gaining by the element, it is known as its valency. Okay, and if it is 6, you can say, so 2 electrons are short by 8 electron in the valence shell, so 2 will be its valency. Okay, so if valence electrons are 5, 6 and 7, so definitely it will gain electrons to complete octet and it will form negative ion, which are called anions, and a property mainly by non-metals we said generally. Okay, so you can also assume by writing the example there, it is 2, 8, 1 configuration of sodium we all know. So after losing of this electron, basically, there will be 8 electron in the valence shell of sodium. So it will lose this electron. Remember that in this condition, because by losing one electron, so one proton is greater in sodium, so it will form Na plus there, so it is cation. Okay, and so the number of electron lost there, it is called valency. And if we say oxygen, so you know it is 2 6 configuration, so it is short of 2 electron, you know, from the octet, so it will gain, so gain will be written on the same side, but loss will be written on the opposite side, you can see. Okay, so it will form O2 negative, 2 negative, indicating that 2 electrons are greater than the number of proton. Okay, better. So it is the valency, simply so simple, the number of electrons gained, lost or shared by an atom to complete octet in its valence shell. Okay, so if there are 4 electrons, so definitely it will share. Okay, because for gaining or losing of 4 electrons, the large amount of energy required, so which is not possible by the atom. Okay, so that's why it will share the electrons. It means you can write here also, if it is 4 electrons present, valence electron, so it will share the electrons. Okay, beta. Okay, then the molecular formula. How can we form formula? Formula, you, if you know the valency, then you can draw formula very easily. Like I'm writing some values here. It is oxide, we all know. It is nitrate. It is chloride. It is nitrite. It is called hydroxide. Remember that the negative sign present there, these are its valency, means 1. It is called nitrate. It is chloride. It is nitrite. Okay, and it is hydrogen carbonate, HCO3 negative, means there is one valency basically. Hydrogen carbonate. So they have one valency because of only one negative charge is present there. Okay, and one also we have, it is acetate, you know, I think it is called acetate. Okay, then we have sulfide, it is sulfate, it is carbonate, it is oxide basically. So as 2 written here, it means there is 2 valency. It is sulfide, it is sulfate, it is carbonate, it is oxide. Okay, then we have, you can say PO4 3 negative. So these are very general ions I'm writing here. It is phosphate basically. So it has 3 valency because of 3 negative charges present here. Okay, and for metals you all know generally the number of positive ions present there, it will be its valency. Okay, so now if we say a simple example for us, it is sodium chloride that we want. Very first that we want is sodium chloride. So simply we all know sodium, it has one valency, and for chloride, because written here, it is also valency 1. So we will cross the valency and it will gives us formula of the compound. Like if we say, if it is sodium oxide, now if we have, so we all know valency of sodium is 1, and for oxide, you know, 2 negative there was because of, so it will be 2. So it is the simple oxide that we have because of, so it will be Na2O. It is the oxide formula of sodium. Okay, then if we say magnesium, magnesium chloride. Okay, so we all know now magnesium, it is 2 valency, and for chloride it is 1 valency. So by the cross multiply you can get the formula, it is MgCl2, and if you write magnesium oxide now, magnesium oxide. So in this case we all know the valency of magnesium and oxygen both are same, so we can divide it, so it will be 1 1 will be the final value, you can say. We have to find the smallest ratio for the valency, you can say. Okay, so it will be magnesium oxide like this. So by this formula you can write the formula of any compound if you know the basic points. Like I want aluminium bromide. You all know fluorine, chlorine, bromine are the same group's elements, so one valence will be there. Okay, so for aluminium there will be 3 valency, and for bromide there will be 1 valency will be there. So by this it will be AlBr3. If you write aluminium oxide, aluminium oxide, so what will be the formula? It will be 3 valency, and for oxide it will be 2. So it will be Al2O3. So these are some simple terms that we're talking about. And now you can form the formula like carbonate, sulfate, nitride, like all of these very easily. Sodium. Okay, no, sodium we have done lots of time because of. So now it is potassium. Potassium nitride. So now main thing is nitride means nitrogen gaining of 3 electrons. So it is nitrogen and having the 3 valency. So its formula will be K3M, potassium nitride. If you want to write magnesium nitride, magnesium nitride. So same, it is 2 and it is 3 valency unit. So it will be Mg3 and 2. It is magnesium nitride. So you can write any formula for the compounds here. Okay. I hope you all got this point, and if you have any doubt, please give me a message. If you have any queries, I will tell. Okay. Okay. Bye. Take care, everyone.